Hi everyone, my name is Mr. Sodmish Ale, working as a assistant professor in College of Engineering Fulton. Today I am teaching the third chapter, that is field astronomy. So, field astronomy is the branch of surveying used to determine the position of different celestial bodies such as sun, moon, different star and planets with respect to the horizon, equator and earth, right? So purpose of field astronomy gives the position or location of any line on the surface of the earth with respect to the celestial bodies. Next, determination of absolute location of the celestial bodies such as sun, star, planets, moon. Next, used to find out the angular position of star, position of point on the earth's surface and determination of the orientation. Orientation is nothing but the position of different celestial bodies with respect to the each other. So in that we have to take spherical trigonometry and spherical triangle. Firstly we can see what is meant by sphere. A sphere is a surface obtained by revolving this semicircle or circle, right? A simple example of sphere is a cricket ball, volleyball or a basketball. It is a sphere, right? Suppose we can take the any point on the surface of sphere, right? It is lying at a equal distance from the center. If we cut the sphere at any plane, the resulting section may be a circle. That is, if we cut the olive oil by a plane, if you observe this cutting plane, it may be a circle, right? And after cutting we get the two type of circle. It may be a small circle or it may be a great circle. Firstly, small circle. This is small circle in diagram. Small circle is a circle obtained if the cutting plane does not passing through the center of the sphere. If cutting plane does not passing through the center of sphere, then we can get this small circle. And great circle, if cutting plane passes through the center of the sphere, we get a great circle, right? And any axis perpendicular to this great circle or small circle is known as the cutting axis or axis of cutting, right? So in that equator is a great circle, right? Equator is a great circle which is perpendicular to the north and south pole. So in this diagram, north pole and south pole, the great circle perpendicular to this north and south pole, that is a line axis passing through the north pole and south pole. And the great circle which is perpendicular to the such axis or polar axis is nothing but the equator. Or equator is passing through the east and west pole and the center of the earth or center of the celestial sphere, right? So spherical triangle is obtained by intersection of the arcs of the great circle, right? In figure ABC is the spherical triangle which is obtained by intersection of the three great circle, not a small circle, three great circles, right? And these are the different properties of the spherical triangle. We can know these properties of the normal triangle, that is summation of all the three angles is equal to 180 degree, right? In such a way that there are different properties of the spherical triangle. Its first property is any angle is less than the two right angles. That is, if you take the any angle, that is was in previous figure angle ABC, if you take angle B, the value of angle B should be less than 180 degree. Next, the sum of three angles is less than six right angles or 3 pi. The summation of three angles should be less than the six right angle. Next, the sum of length of any two side is greater than length of one side. That is, if we take the summation of any two side, it should be greater than the another third side, right? Next, the smaller angle is opposite to the smaller side. It is same as normal triangle. That is, if length of side in front of the small angle should be less, right? Next, sum of three angle of a spherical triangle is greater than 180 degree. If you take the summation of all the triangle, it should be greater than 180 degree, and this value is nothing but the spherical axis. That is, the suppose sum of triangles of a spherical triangle is 210 degree, then 30 degree is nothing but the spherical axis of the spherical triangle, right? So different terms used in this field astronomy. First one is celestial sphere. So celestial sphere is a imaginary sphere. Imaginary sphere, its radius is infinity. According to study area, we can increasing the radius of the celestial sphere, right? And center of the celestial sphere is the center of the earth. It is from the center of the earth we can increasing the radius, right? Radius maybe infinity, right? This is the simple diagram. This is the celestial sphere. In diagram they have shown celestial sphere and different bodies lying in the celestial sphere, right? So next term is zenith. Zenith, the point on the celestial sphere immediately above the observer station. In diagram, suppose we are observing the any body, celestial body from the earth surface. So point exactly above the observer is nothing but the zenith. Next, nadir, the point on the celestial sphere vertically below the observer station. Zenith is the above and nadir is the point below the observer, and these are the point lying on the celestial sphere, right? Next term is celestial horizon. So celestial horizon, it is a great circle, right? A great circle is nothing but the circle passes through the center of the celestial sphere, right? The horizon is the great circle which is perpendicular to the zenith and nadir line. The line joining the zenith and nadir is nothing but the zenith nadir line, right? And the horizon or a great circle which is perpendicular to such a line is nothing but the celestial horizon, right? Next one is sensible horizon. Sensible horizon, it is the circle, it is nothing but a small circle, right? It is the circle which is exactly tangential to the observer station, right? And it is passing over the surface of the earth. Next point is celestial equator. Celestial equator is a great circle which is perpendicular to the north and south pole, perpendicular to the north and south pole. Next one is vertical circle. A vertical circle is a great circle. Vertical circle is a great circle passing through the zenith and nadir point. Suppose we can take any great circle, and if it intersect or if it passes through the zenith and nadir, then such a great circle is nothing but a vertical circle. Next, meridian. A meridian is a vertical circle which is passing through the zenith and nadir as well as the north and south poles. There is such a great circle is nothing but the meridian. That is, meridian is a great circle passes through the zenith, nadir, and north and south pole. This is nothing but the meridian. Next one is latitude and longitude. So this is the diagram, latitude and longitude. Latitude is measured along the meridian and longitude is measured along the equator. So firstly we can take the latitude. in the vertical direction we can measure that along the meridian, and longitude along the horizontal direction, that is along the equator. So in this diagram there is a point M, and so in order to determine the latitude is measured from the equator along the meridian or along the great circle passing through that point. Suppose we have to measure the latitude of point M, then you can take a great circle which is passing through zenith and nadir as well as point M. So this is nothing but the meridian, and we can take this angle from the starting from equator towards point M and along the great circle or along the meridian. This is nothing but the latitude, and the value of latitude lies between 0 degree to 90 degree. Towards latitude maybe towards north or towards south. If you have measured latitude towards north, its value is positive, and if you measure latitude in a south direction, then its value may be negative. Now next term is longitude. Longitude is the angle measured between the two meridian, that is standard meridian and second meridian is passing through that point, right, whose latitude is to be measured. The standard meridian is nothing but the Greenwich meridian. That is longitude simply angle between the two meridian. Out of that, first meridian is standard meridian, that is Greenwich meridian, and second meridian is the meridian passing through that point whose meridian we have to determine, and its value lies between 0 degree to 180 degree, and it is measured towards east direction or towards west direction, east or west direction. So next term is colatitude. Colatitude is the angular distance measured from the zenith, that is colatitude is equal to 90 degree minus latitude, that is the latitude measured from the equator and colatitude measured from the zenith point. Next, azimuth. Azimuth is the angle between observer meridian and the vertical circle passing through that body. Observer meridian, vertical circle passing through that body. The azimuth is the angle between two vertical circles. Two vertical circles. One vertical circle passing through the north and south pole, and second vertical circle passing through that body whose azimuth is to be measured. Next term is declination. So it is the angular distance of any body measured from equator along the meridian. So declination is nothing but the angular distance measured from equator along this meridian. So this diagram shows the value of the longitude. The 0 degree angle is nothing but the Greenwich meridian, and here towards left there is a east, and towards right there is a west. Next term is co-declination. Co-declination is the angular distance of any body from the poles. From the poles, right? Here it is co-declination is equal to 90 degree minus declination. Next one is altitude. Altitude, it is the angular distance above the horizon of any heavenly body measured along the vertical circle passing through that body. That is altitude is nothing but measured from the horizon, and horizon is the great circle which is perpendicular to the zenith and nadir. So altitude is measured from the horizon along the vertical circle passing through that body. Suppose we are observing the moon, so and our observer station is earth, right? Earth. So horizon is the great circle perpendicular to the zenith and nadir. Zenith is present exactly above the observer station, and nadir is the point below the observer station, right? So, and a vertical circle is the circle passing through the zenith and nadir point, and altitude is the angular distance measured above the horizon of any heavenly body measured along vertical circle passing through that body. This is altitude. And co-altitude, or it is also known as zenith distance, and it is equal to 90 degree minus altitude. That is, it is measured from the zenith towards body along the vertical circle. Next term is hour angle. Hour angle, it is the angle of heavenly bodies between observer meridian and the declination circle passing through that body. And last term is right accession. Right accession, it is also angular distance along the equator measured towards the east from first point of Aries. These are the different terms used in the field astronomy. So in order to determine the position of any celestial bodies, we have three coordinate system. First one is altitude azimuth system, second one is declination hour angle system, and third one is declination right accession system. So what is my coordinate system? Coordinate system is the system used to define the position of any point, right? Any point. In general, we can use the x and y coordinate, right? X and in 2D format. This is also the 2D format. Altitude and azimuth system, declination and hour angle system, and declination right accession system. First, altitude and azimuth system, it is, we can define the position of any celestial bodies by measuring its altitude and by measuring its azimuth. So this is the diagram. In that, we can determine the position of star by measuring the azimuth and by measuring the altitude. Next is, we can determine here position of star by measuring the declination angle and by measuring the hour angle, right? And next, third one is, we can determine the position of any point by measuring the declination and by measuring the right accession, right? I hope you have understand this third chapter, that is field astronomy.